Right. Greetings to you, grade 11s. Welcome to EduBlight Spiritual Academy. We are an exciting virtual school which caters for mathematics, physics, accounting, and in the near future we'll be developing all your learning areas so that you can always review classes at the convenience of your homes. Today, I am going to look at trigonometry. I'm going to look at trigonometry. Okay, let me just give you a brief about myself before I get into this. Right, the experience that I have with learners over trigonometry is it's difficult. Some they will say trigonometry is tricky. Right. My name is Makore. I've been teaching these things for years. And I'm still teaching grade 12s. So I've got vast experience in developing this concept. So I just urge you guys to be very, very attentive and be faithful to yourself, and please follow us through as I'll be developing this. If you are consistent in following up on the lessons as I'll be developing them, I'm sure your life will never be the same again, and your perspective on this section will be different. This is one of the simplest sections that I've ever encountered. So remember, your trigonometry for matric develops now. So let's try to go through this and understand the concept together as we are unpacking it. All right. Now, like I said, I'm going to look at trigonometry. Now, remember in trigonometry, this is something that started in grade 10, and in your grade 10, you are looking at this thing from a basic perspective. So, in grade 11, it's just a continuation of some of the concepts that you did and you left them hanging in grade 10, right? Trust me, it's a beautiful section, and I'm sure we are going to enjoy this together. Let me prepare your board there so that let me just prepare your board. Okay, right. Now let's look at this. Trigonometry. Trigonometry. From your lower grade, we defined what trigonometry is, and we said it is the study of the relationship between the angles and the sides of a triangle. Now, in grade 11, this is going to develop from the analysis of angles. We are going to develop this from this perspective of the analysis of angles. Okay, now, the first thing that I'm going to talk about is angles. They stretch from negative infinity to positive infinity, meaning to say you've got positive angles and you've got negative angles. Okay, right. If I'll take you back to your grade 10, you ended at the cast diagram. If you remember very well, your grade 10, you've passed that grade, yes. Remember the cast diagram, right, where you were looking at things like that. Okay, now that is your Cartesian plane, and this is your cast diagram. And we said if angles are measured in a clockwise direction, which is from 0 to 90, anti-clockwise 180, 270, then 360. Right. Now, as you rotate on and on in an anti-clockwise direction, the types of angles that you are building are positive angles. All angles that are positive, it means they are measured in an anti-clockwise direction. Okay, right. And all negative angles, it means they are measured in an anti-clockwise direction. If 0 is there, it means you are going in that direction. That is the clockwise direction. Okay, so we are saying in trigonometry, when we are studying angles, the first thing is you've got positive angles. And I'm basically saying all positive angles are angles measured in an anti-clockwise direction. In an anti-clockwise direction. Say, for instance, you want to measure 30 degrees. You come and draw something like this. There you go, and you measure going in this direction, which is the anti-clockwise direction. So this is how you present positive 30. Okay, right. Now, likewise, negative angles. Remember, I said angles, they stretch from negative infinity to positive infinity. Negative angles, these are angles which are measured in a clockwise direction. Okay, in a clockwise direction. Anything positive, it means anti-clockwise. Anything negative, it means clockwise. So if I want to measure negative 30 degrees, it means I'll go in a clockwise direction. There you go. This would be negative 30 degrees. Good. Right. Now, I want us to go back to revision of your cast diagram. Something of this sort, which is basically looking at trigonometric ratios or analyzing trigonometric ratios in the first revolution measured clockwise. Meaning to say, I'm going to start from 0 there, then 90 degrees there, 180, 270, something like that. Now, from 0 to 90, any angle which is between 0 and 90, call that angle theta. Any angle between 0 and 90, we call that quadrant, or we say that particular angle is in the first quadrant. Right, you guys are grade 11. I guess you understand what a quadrant is. Remember, a quadrant is a word which is deduced from quarter. Where is the aspect of quarter coming from? Remember, the first revolution stretches from 0 to 360. And if I divide 360 by 4, I will get the 4 quarters, which can also be called the 4 quadrants. Okay, quad means 4. So the first quadrant takes all values from 0 to 90. Then from 90 to 180, this we call it the second quadrant. The second quadrant. Now from 180 to 270, we call it the third quadrant. Okay, then lastly, obviously from 270 less than theta less than 360, this we call it the fourth quadrant. Now this is how you can cluster your angles in different quadrants. First quadrant from 0 to 90, second quadrant 90 to 180, third quadrant 180 to 270, then lastly 270 to 360. That's the fourth quadrant. Now, The next thing that we are supposed to do is to investigate how our trigonometric ratios are going to behave in different quadrants. I've got three basic trigonometric ratios from your grade 10. The first one, it was the sine ratio, cosine, and tangent. Then we also gave you their reciprocals. Remember the cotangent, the secant, and the cosecant. That was grade 10. Now, I want us to look at how these trigonometric ratios are going to behave in each and every quadrant. Then we conclude. Okay, now, I'm going to start with the first quadrant. Please take your calculator. Get a calculator quickly so that we can do this short investigation together. Take your calculator. Let's go to the first quadrant. I said first quadrant. You are talking about angles between 0 and 90. Now, what I want you to do, grade 11, is take your calculator, do it with me. I want us to see the behavior of these basic trigonometric ratios in this quadrant. Let's start with the first quadrant. I'm going to say, let's pick any angle that you can think of. Any. Someone can say from 0 to 90, I'm choosing 2 degrees. That's your choice. Someone can say between 0 and 90, I'm choosing 20 degrees. It's fine. For argument's sake, I'm just going to pick 60 degrees. Is 60 between 0 and 90? Yes. So it's in the first quadrant. So I'll say 60 degrees. There you go. I'm going to go to your calculator and say evaluate sine 60. I'm mostly interested in the sign that it presents, the sign that the answer presents. That's the one that I want, because I want to see how, in terms of the sign, this trigonometric ratio behaves in the first quadrant. So if I take sine 60 degrees and say sine 60 on your calculator, say equals, my question is your answer positive or negative? Don't give me the whole answer. I just want to know if the function is going to be positive or negative. According to my calculator, I don't know about yours, it's giving me positive square root of 3 over 2. So sine 60 is positive. If you use 2 degrees, say sine 2 degrees, press sine 2 degrees. 2 degrees is also in the first quadrant. Is it positive or negative? It is positive. Try any angle that is in the first quadrant and attach it to sine as your reference angle. Sine 45 degrees. I'm getting root 2 over 2, which is positive. So it means once sine is in the first quadrant, it is positive. Okay, let's go to cos 60 degrees. Take your calculator quickly. Say cos 60 degrees. Cos 60 degrees, it's also a positive. What is tan 60 degrees? Pick any angle, any acute angle, any angle between 0 and 90 degrees and attach it to your ratios. We want to see the type of a sign that is going to present. Right. Now, tan 60 is also positive. So we can conclude. What is it that we can conclude? In conclusion, I can claim that all trigonometric or trig ratios are positive in the first quadrant. Powerful. All of my trigonometric ratios are positive in the first quadrant. We discovered that. How nice is that? Let's look at the next one. The second quadrant. I said the second quadrant, it stretches from where? From 90 to 180. So the question is, pick any angle in the second quadrant, attach it to the ratios that we have. I'm going to take sine 120. choose not to take 120 with me, and also use a different angle. As long as it's in the second quadrant, someone can say sine 100 or sine 91. So I've got there cos 120 tan 120, something like that. Let's investigate the signs. Look at that. Sine 120. Is it positive or negative? My calculator gives me a negative. I don't know about yours. Right? Cos 120. My answer is a negative. Don't worry about the figure. Worry about the answer. Right? Tan 120. It's a positive. Tan 120 is actually a positive. Sorry about that. It's a positive. Okay. Now, what can we conclude? In conclusion, I can say only tan theta is positive in the second only tan. Okay, press sine 120. Sine 120 is a positive. Cos 120, please redo that. It's a negative, yes. Tan 120, it is a negative. Right. Now, in conclusion, we can say only sine, sorry about that, only sine theta is a positive in the second quadrant. Okay, thank you. Right. Now, let's look at the second one, which is we're now in the third quadrant, and we want to see how the third quadrant behaves. Right. I'm going to pick an angle in the third quadrant. Remember, third quadrant takes values from now 180 less than theta less than 270. Right. I want you to pick any angle which is between 180 and 270. This is going to be what? I'm going to say first one sine. Let's pick any angle. I'm just going to pick 201. I'm going to pick cos 201, tan 201. Those that are faster than me, already I'm sure you've got the signs. Sine 120, sine 120, if you press it, it's going to be, it's a negative. Cos 201, 201, it's also a negative. Tan 201, tan 201, it's a positive. Okay, right. Now, what can we conclude? We can say, in conclusion, in the third quadrant, once you pick any angle in the third quadrant, only tan or the tangent ratio is positive in the third quadrant. In the third quadrant. Now, let's look at the last one, which is the fourth quadrant. Right. If you look at the fourth quadrant, I'm taking angles from 270 less than theta less than 360. That's the fourth quadrant. Pick any angle between that and that. Someone can say sine 300, cos 300, and tan 300. Press sine 300, it's a negative. Cos 300, it's a positive. Tan 300, I'm sure it's a negative. Conclusion. In terms of conclusion, we can all say only what? Only the cosine ratio is positive in the fourth quadrant. Okay, now if you look at this, the fourth quadrant, the third quadrant, and the second quadrant, something like this. Now, one thing that I'm supposed to develop on is once you reach the fourth quadrant, on your cast diagram, you are about to go on the second revolution. Once you reach the fourth quadrant, it means you are about to go to the second revolution. Meaning to say, if you are on your cast diagram like this, remember in grade 10, you develop what a cast diagram is. It was simply summarizing that from the conclusions that we made. It means in the first quadrant, all trigonometric ratios are positive. In the second quadrant, only sine is positive. On the third quadrant, only tan. And lastly, in the fourth, we call it what? Only cos is positive there. Right. Now, cast, it was developed from this to summarize that all sine, tan, and cos. This is something which is supposed to be a part of us. Whenever we're analyzing our trigonometry, we should always know that if this angle is in the second quadrant, only sine is positive there. So this person named this diagram to call it the cast by taking C, then A, S, T. Hence, we can call it the cast diagram. There are a lot of other abbreviations that we can use. Some, they developed a lot of other plays that can represent all in the first quadrant, sine positive in the second, tan in the third, and cos, by saying all science teachers take coffee. Okay, just to master the arrangement of the behavior of your basic trigonometric ratios on your cast diagram. Okay, right. Anyway, before I proceed, it is also important that angles, they don't start from 0 to 360. No. I said angles, they start from negative infinity to positive infinity. So in a sense, it means if I put 0 there, 90 there, 180, 270 to 360, then if I go for the second revolution, it means now there I've got 450, then I'll turn, this will be 540. This is the second revolution. Then I've got 630. From 630, I'll go to 720, something like that. Now, the most important thing, or my point is, the fifth quadrant, if you go to your calculator now and pick an angle which is between 360 to 450, which is the fifth quadrant. Okay, let me just try it so that I can conclude. The fifth quadrant. You realize that if I take this as sine 400, any angle in the fifth quadrant, cos 400, any angle, tan 400, what is going to happen? Look at this. Take your calculator. What is sine 400? It gives you a positive. What is cos 400? It also gives you a positive. What is tan 400? It also gives you a positive. What are you observing? The fifth quadrant behaves like the first quadrant. In like manner, the sixth quadrant behaves like the second quadrant. The seventh quadrant behaves like the third, and the eighth quadrant behaves like the fourth quadrant. So I don't need to replicate this. You should know that all the quadrants that comes after the fourth quadrant, they behave like the underlying quadrant in the first revolution. Okay, right. That's basic information that you need. Right. Now, having said that, let me give you an illustration. Where is this taking us to? Right. Let's look at a typical example. Let's look at an example. My example 1 there. Let's look at example number 1. Decide whether the following functions are positive or negative without the use of a calculator. Now, I'll ask you to throw your calculators away. Please run away from your calculator, put it away. I want us to do this, the same process, but without the calculator. Right, I'm given trigonometric functions there. Say cos 200, then I've got C, which is sine 114, something like that. Right, now look at this. I just want us to simplify these things without the use of a calculator. Please underline that part. Take your calculator away. I want to decide whether tan 311 is positive or is negative. Is it positive? Is it negative? I'm going to come and say, the first thing, what determines whether a function is going to be a positive or a negative? I'm going to look at the angle. Now the angle is going to guide me. If I look at 311, which quadrant is that? Where is 311 on your quadrants? 311, if you quickly go to your cast diagram, you will see that 311 is between 270 and 360. So it means this angle is in the fourth quadrant. Now, if it's in the fourth quadrant, what is tan in the fourth quadrant? Is it positive? Is it negative? I'll go back to my cast diagram. Tan is negative in the fourth quadrant. Hence, this function is going to be negative. Good. Look at the next one, B. Cos 200. Look at 200 degrees. First, go to your cast diagram. Locate 200 degrees on your cast diagram. Which quadrant is that? 200 degrees is between what? 180 and 270. That is the third quadrant. So this angle is in the third quadrant. Good. If it's in the third quadrant, what is cos in the third quadrant? Is it positive? Is it negative? Indeed, it is negative. Remember, cos is positive only in the first and in the fourth quadrant. Okay, right. Lastly, look at sine 111. Sine 111, 114, sorry. Sine 114, is it positive or negative? I'm going to be guided by the angle. Where is this angle? Is the angle in the first quadrant? Is the angle in the second quadrant? Yes, this angle is in the second quadrant. Why? Because it's between 90 and 180. So this is the second quadrant. If it's in the second quadrant, what is sine in the second quadrant? Second quadrant, sine from the cast diagram is positive. So I can basically look at all the angles that you can think of, whether positive or negative. I should be able to decide whether they are going to be positive or negative, right? Look at this. Sine negative 10. Just want to plug a negative angle there. Good. Okay. Sine negative 10 degrees. The first thing is to locate where this angle is on your quadrant, but it's a negative angle. Be careful. So I'll go to my cast diagram and measure 10 degrees in a clockwise direction. I will land in the fourth quadrant. So negative 10 degrees is actually in the fourth quadrant. And what is sine in the fourth quadrant? It is negative. Simple, straightforward. Let's look at the second example. Example number 2, our last example there. Then an activity will come your way. Look at the activity, attempt it in like manner, trying to locate whether the function is going to be negative or positive without the use of a calculator. Okay, now let's look at example number 2. In which quadrant does theta lie? Okay, where is theta? If the condition says A, tan theta is greater than what? 0, and what? Sine theta is less than a 0. This one, very interesting. I want to position angle theta, or I'm trying to guess where is this theta? In which quadrant does this angle lie? Which makes tan greater than 0. Anything greater than 0, we know that it's positive. And sine of the same angle will be less than a 0. Anything less than a 0, it's a negative. So I'm looking for where tan is positive. At the same time, sine is negative. Then I'll be able to locate the quadrant where this theta belongs. Okay, fine. Simple. Look at how I'm going to approach it. I'll go to my cast diagram. Draw a Cartesian plane like that. Okay, I've got my quadrants 1, 2, 3, 4. You can see that. I'll start with the first condition and say theta, tan theta is greater than 0. Then I'll ask myself, where is tan positive? Because greater than 0 simply means positive. Anything greater than 0 is positive. Where is tan positive on your cast diagram? Obviously, tan is positive in the first quadrant because all of them, they are positive. Where else? In the third quadrant, tan is positive. I'm done with the first condition. I'm now going to the second restriction. What does it say? Sine carrying the same theta is now negative. Then I'll say, where is sine negative? Sine is negative in the third quadrant and in the fourth quadrant. Now the question is, which quadrant satisfies both conditions? The quadrant is what? The third quadrant. So theta, in conclusion, we can say, therefore, theta lies in the third quadrant. There you go. What does that mean? If you pick any angle in the third quadrant right now and give it to tan and you give it to sine, you realize that tan will be a positive while sine will be a what? A negative. Okay. The second one, let's look at your B. Same question. In which quadrant does your theta lie? I'm going to look at this one now. Cos theta greater than 0 and sine theta less than a 0. Okay, right. Look at this. Same thing. Draw your quadrants. Analyze one by one. Cos theta is greater than 0. Anything greater than 0 is positive. So I'm looking for where cos is what? Positive. Sine theta is less than 0. Anything less than 0, it's a negative. So I'll now come. Cos is a positive. Where is cos positive? In the first and in the fourth quadrant. Where is sine negative? In the third and in the fourth quadrant. So where does our theta lie? Theta lies in the fourth quadrant, because the fourth quadrant satisfies both conditions. Okay, there you go. Let's look at my last example there. Then you guys you look at the following activity. Please look out for the activity on the platform so that you can exercise this knowledge. Okay. And also, this is 0 less than theta less than 180. Okay, now let's look at this one, presented slightly different. In which quadrant does theta lie? Very simple. I'm going to draw my Cartesian plane, and I'm going to say, okay, now this is 4 tan theta plus a 3 equal to 0. I'm going to make tan theta subject so that I'll be able to tell whether a tan theta is a positive or it's a negative. So I'm going to say quickly 4 tan theta, making tan theta subject. So this is going to be 4 tan theta equal to negative 3. Divide that by 4, divide that by 4. Your tan theta is equal to negative 3 over 4. So this is a negative. So tan theta is a negative. I'll go back to my cast diagram. Where is tan negative? Second and fourth quadrant. Okay, I'll come to the next one. It says theta takes values from 0 to 180. Remember, 0 is there, that's 90, that is 180, 270, and 360. Which quadrants are between 0 and 180? It is quadrant 1 and quadrant 2. Which of the quadrants satisfies both conditions? It is actually the second quadrant with 2 crosses. So it means, therefore, theta lies in the second quadrant. Right. Thank you so much. This is how the trigonometric ratios behave in different set of quadrants. I'm going to give you guys an activity on these things. You need to apply your knowledge. It's exciting. It is nice. It is simple. You can do this on your own. I believe if you take time with a friend and you attempt this, this will definitely help you in developing your trigonometry. So allow me to say we've started this journey together. Hang on. Let's develop these things together. EduBlush, we do not believe in just hit and run. We are interested in developing you, not only to pass exams, but to become a better citizen and to live your dream as a learner. Thank you so much. Thank you for your time. God bless you.